All right, guys. So this is where we left off in 5.1. With example 3, we went through and found all of the combined operations, right? So we added, we subtracted, we multiplied, and we divided. Okay. So on part B of this, we're going to now plug in values and evaluate.
Just do a 5.1.
So we're going to plug in and evaluate. So we already have our functions. Now we're going to evaluate at these functions. So here, if I have f plus g at 5, well, what was f plus g? What did we get for f plus g?
X squared on the x squared of x.
So
is that the first?
Yeah. So for f plus g, we got what?
X squared plus square root of x.
X squared plus the square root of x. So therefore, for f of f plus g of 5, everywhere there's an x, I'm going to plug in a 5. So we have 5 squared plus the square root of 5. And that's going to equal 25 plus the square root of 5. Okay, we're going to leave it in exact form. If it asks for approximate value, then I would then go to a calculator. Does that make sense? Okay. When we did f minus g, what did we get?
X squared minus square root of x plus 2.
I didn't mean to put a plus.
Oh.
I didn't mean to put a plus. Great. Plus 2, right? So then now when I plug in, I'm going to end up with 25 plus 2 is going to give me. So we have 25 minus the square root of 5 plus 2. And that's going to give us 27 minus the square root of 5. How do we feel about evaluating?
Why are we inputting 5 for f minus 1?
Oh, it said 1, didn't it?
Yeah.
Because Miss Jones reread what she saw. Like a very special person. There she goes. 1, 1, 2. And what is that going to equal? Just 2. Okay. When we did f times g, what did we get?
We got x to 5 halves minus x squared plus x halves minus 1.
X squared minus x to the half minus 1.
I don't like that. Halves plus
And now we're substituting in 0. So what's going to happen to all these x's?
0.
It just becomes 0. So 0 minus 1 equals
0.
negative 1.
Oh. I know it's not a
It's equals with an arrow. Greg.
Oh my God.
Sure. All right. And then what do we get for f divided by g?
X squared plus x and a half minus 1.
And now we're substituting in 3. So just for, I don't feel like plugging in a calculator, we're going to leave it as it is. So we have 3 squared plus 1 divided by 3 to the half minus 1, which is just going to give us 10 over square root of 3 minus 1. And I can plug that in and actually evaluate it, right?
Is that a 3 or a 7?
You're still blind.
Is that a 3 or a 7?
A 3. All right. How do you feel about evaluating?
So right now. Not hard. Well, like, if it's just like this, then we're just filling in the blank, right?
Yeah. So this is the part that you had to come up with first, right? Finding the operations, well, doing the operations and finding the functions. And then now you're using them. Okay. Questions, comments, concerns. Do you feel like we need more examples? Do we feel comfortable with it? Good. So if you have a quiz over something like this tomorrow.
See, look, I'm good now.
Uh-huh.
Well, I'll look at the quiz.
Uh-huh.
Forget.
One more thing.
Another example. Of which operation?
You said when we do, subtraction, right, we have to change the side on the right side. Side.
When you are subtracting?
Yeah.
So when you're subtracting, you have to distribute the subtraction to the whole expression.
Yeah, that's what I'm-
Yeah. Did I make up another one? I can make up another one. I mean, which part of it were you stuck on? Adding, subtracting, multiplying, dividing? What'd you say? Okay, so in this case, like for here, all you're doing, instead of doing F divided by F over G, what if we had G over F, right? And I need to find F of X. That means I'm just literally taking the G function, which is square root of X minus 1, and dividing it by the F function, which is X squared plus 1. If I can reduce and simplify and eliminate, I would. But if there's nothing to simplify, reduce, then this is your combined function. Okay, and then when you're evaluating, so let's say that I'm going to let this be 2. I shouldn't have chose 2. Choose a prettier number to work with. 4. So now we're finding G divided by F of 4. Everywhere that there's an X, it's going to become a 4. So this is going to give me 2 minus 1 over 16 plus 1, which gives me 2 over 17. I wrote 2, didn't I? Because I'm tripping.
Second time.
Second time, you know?
Yeah.
There we go. You saw nothing. This is proof that I haven't taught anything at all today. This very moment.
Why you choose to teach your art class?
My other classes were taking the TSI math test. What am I supposed to teach while they're doing that? They're taking out that. Okay, my bad. All right, but yes, so that's what it means. So when you're finding the expression, and then when you are evaluating. All right, so here is a real world example of where combination of functions may come into play. All right, and I know it's DVDs and we don't use DVDs anymore, but we're just gonna roll with this, okay?
Oh, roll.
Once the soundtrack for a DVD has been recorded, the cost of producing the master disc can be significant. After the disc has been made, additional discs can be produced inexpensively. A typical cost for producing the master disc is $500, while additional costs cost $4.50, and each album sells for $9, okay? Assume no other expenses. Find a function C that outputs the cost of producing the master disc plus X additional DVDs. Find the cost of making the master disc and 1,500 additional DVDs. All right, I'm going to pause and I'm going to let you do what you think you would have to do to solve this problem. Okay, so do whatever math skills you think you need in order to solve this problem.
109.
Okay. So per cost, so my cost is just 500 plus 450, right? It literally tells me in words, your output is the cost of the master
And the X is 1,000.
plus X additional DVDs.
The X is 1,000.
So now when you evaluate, exactly. So now when I'm evaluating, I'm looking for C at 1,500. So if I make 1,500 additional, that means I have 500 plus 4.50 times 1,500. Did anyone get this? Please tell me. Someone did.
I didn't write it like that, but it's set up like this. Yeah.
That's your cost if you wanted to make 1,500 CDs.
Yeah.
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 Okay. So remember I told you that word problems are really not the hardest mathematically.
Yes, it is.
It's you trying to use the math sense and your common sense to create it, that comprehension skill. Once you have, look at the math. Was that difficult math? For the people who say, yeah, forget you. All right. So here it says, suppose that the DVD is sold for $9. Find a function R that represents the revenue for selling the DVDs. So our revenue
So if the
equals 9 times X, right?
Yeah.
So now I'm looking for R of 15. 1,500. If I sell all 1,500 DVDs, How much am I making in revenue
For $9.
for $9? 13,500, right? That's my revenue. That's how much I made. I didn't mean to write P on the last slide, by the way. I meant to write an R for revenue. I got ahead of myself. Okay, your profit is your revenue minus your cost. Does that make sense? Profit is, so if I want to know how much I profited, my profit equals my revenue minus my cost, my R minus my C. This is why it becomes a combined function. Because I'm combining my two functions to figure out what's happening. Okay? So if I wanted to make a full and final profit cost, this would be R, and the formula for R was 9x, and the formula for C was 500 plus, right? That would be, so now that I know, I forgot my X. Now that I know what my formula is, instead of me having to do it in parts, every time I want to find my profit, I can just use a simplified formula. So my simplified formula would be 9x minus 450, which is 450x minus 500.
Wait, what? Can you say that again?
I would subtract 9x minus 500. They don't combine, right? But 9x minus 450 is
Oh,
450x, right? They're combined, they're like terms, so I can do the operation. So from now on, if I'm looking for how much I'm going to profit, I'm only going to use that one formula. So I'm going to profit, my profit is going to equal 450.
I feel like you're wording this a lot harder than what it has to be.
Okay, tell me what words did I use?
Right. I mean, like, yeah, you're correct. It's just like, it just seems like a lot more than.
Yeah, you could just do the exact same thing by just getting your revenue minus your expense line.
Yes, that's what I just said.
That's way simpler.
No, okay. I'm saying, yes, you have your two separate situations, right? I can have a revenue formula. I can have a cost formula. But if I'm a business person, I don't want to have to find them separately every single time. So the purpose of the combined function is to create one function that I would use from here on out.
Okay, I see what you mean, like, but could you, like, yeah, I see what you mean, to do it all together, but wouldn't it still be more simple to just get the total of the revenue and total of the cost and then subtract that?
Yeah, I guess I'm trying to get you to see that, yes, you have the skills to do it. All the combined function is saving you 2 steps. So from here on out, if someone came up to me and said, I want you to sell 3,000, make 3,000 DVDs, and they want to know the profit, instead of me having to solve that in 2 steps, now I have a profit formula where I just do it in 1 step. Yeah, so the goal is to build you up. C is your total. Yes, can you do it in parts A and B and then do the subtract? But the goal is to create one function where you can be efficient and get it done. Because in business world, you want to eliminate as many steps as possible, but still be efficient.
I think it was more complicated because we already solved for revenue and expenses.
Yes,
So
yes.
If we had just done this first, it would have made more sense to it.
Yeah.
Okay. Well, the goal is hopefully build your skills. Like, I just wanted you to know you already knew what we were doing, and all we did was combine it. Okay. So now from here on out, if I need to find the profit, I just have to use this one thing. Okay. So 450 times
I
50.
completely understand what you're saying.
Yeah. But now you don't have to ever do it again. Sometimes it's that whole I'm a work smarter than harder thing. And if I could do something, figure out a way to do something quickly, let's say it took me 30 minutes to figure it out, but it's now going to save me an hour every single time, then it was worth my time. Does that make sense?
Yeah.
Okay. All right. So what do we get? What's going to be my profit from 1,500? There we go. So my profit will be 6,250. Now that I'm here, could I also figure out my break-even point?
Yeah.
And in terms of a break even point, that means that my profit would equal what? 0. So I could easily figure out, okay, well, I could set this equal to 0 and now figure out what's my break even point?
How many you get to sell?
What's my minimum amount I have to sell to start making a profit? Does that make sense? So there's a reason why you also build up and you do this is because now you can evaluate it from all different perspectives. Okay, so like in this case, I think I did math. I would have to at least 112 DVDs in order to start making a profit. If I don't sell at least 112, I'm gonna be in the red.
Okay, I guess it was something I was like, fixing, but, for the profit, and instead of adding that 500, you subtracted that because, you know, that's the master disk,
Mhm.
and you're not gonna get money for that?
Exactly,
Okay.
exactly. You're not gonna make any money from that. And you also have to take away the 450 that you had to pay to make each DVD. Okay, all right. This is just practicing evaluating. Do we feel comfortable with evaluating? Anyone's like, oh no, I need to practice plugging in numbers and using PEMDAS. Are we okay? All right, does PEMDAS change just because I changed the letter? No, it actually makes it easier. I just gotta put a K in, keep it pushing, right? Okay, what about now? Is it gonna change?
No.
Okay, now as you're doing this, you may be able to simplify it over. Like I may end up simplifying and evaluating. So here we're gonna go really quick with 2. If I plug 2 in, what's gonna happen first? I'm gonna put it in for X, and that's gonna give me 3 times 2 minus 1 squared plus 1. PEMDAS says I do my parentheses first, exponents, multiply, divide left to right, add and subtract left to right. Agreed?
Yeah.
So we have 3, 1, that's a weird 2, plus 1.
Wait, how'd you go? Go back, real quick.
I didn't go
You wrote it
anywhere.
down, you wrote it down, it's 3, parentheses, 2 minus 1 squared plus 1.
Yeah,
How'd you go from that to,
2 minus 1 is 1.
coming out and distribute?
You do not. PEMDAS says we do what first, guys? Parentheses.
Yeah, but like, since it's right there on the.
I can't, I have to evaluate the inside of the parentheses first.
Parentheses, exponent.
Multiply and divide, add, subtract, left to right.
Parentheses, this thing, and I just
Yeah.
throws a lot of stuff off.
I'm gonna grab the phone. Hold on.
I got it. But I get what you're saying.
Yeah. So now we have 3. 3 plus 1 is 4. Okay, so that's with numerical.
1. I won't be. Yeah, professional that was.
That was very good.
Oh, bad, we're bad.
All right, so now let's look at it with a variable. What if I want to substitute in K minus 1? Is that doable? Like K for X?
We don't have a fan on.
That's okay. K is just now what? X. So we have 3 times K minus 1 squared plus 1.
Is that just like it?
Okay, it says to evaluate. When you evaluate, you want to get rid of powers and parentheses if possible. So in this case, what does that mean I'm doing? It means I have to FOIL because it's squared. So I'm gonna FOIL. That gives me K squared minus K plus 1. Yeah. K times K first, outside, inside, last. All I did was multiply.
And
Okay.
then K squared minus 2.
So that gives me- There we go. So we have K squared minus 2K plus 1 plus 1. Now what do I do?
You distribute.
I'm gonna distribute the 3, right? And when I distribute the 3, I now have 3K squared minus 6K plus 3 plus 1.
Oh, you doing both together, okay.
So then we get 3K squared There we go. Minus 6K plus 4 is what that evaluates to.
See, you almost threw me off again right
Did you
there.
make this,
That make
did you make this problem?
Why?
The plagiarizing. There was a problem? No, I just.
What's wrong with me?
Another letter.
I just kidding.
You're concerning me. All right. So is that process gonna change when it becomes x squared?
Yeah.
It's not. Why would it change?
You just put more parties.
We're just building on, right?
It says it's gonna change from what?
Is it gonna change? Is it gonna be a different process from here to there? Your x values are just gonna increase, right? So instead of it being single k's, it's now gonna be k squared and k to the fourth, and or x
Yeah.
not k's.
So you just correlate you exactly.
So wait. You're replacing that X with X squared.
Exactly. So you're not doing anything different except saying now I have x squared minus 1 squared plus 1. Is that gonna change the process? You're just gonna have a higher x power, right? So everything is gonna be the same. That's why I say when you already have a skill, I promise you, we teach you the skills from beginning to end. If you could do it with a number, you could do it with a variable. If you could do it with a single variable, then you could do it with a squared variable. Okay? Is it what? 2 by 4? To the fourth, yes, to the fourth. So again, after you go through the whole thing and separate, I'm not gonna go through it again, but all you're doing is the same process, right? So when I get all said and done, it's just gonna be 3 x to the what now? 4. And then what?
Minus 6x squared.
Minus 6x squared plus 4. Okay? You can turn this song down. Turn this song down.
Just this song?
No, yeah. It's very, I don't feel like it's very school appropriate, so.
No.
Just gonna let it go. It's on Pandora. I
let
don't
me
pay
get
for her,
options,
so
John.
she gets to play what she wants.
Let me get off you know.
She's free. No.
And
You
break
too.
out this
No.
pretty show.
All right. What about now? Is it gonna change?
Yeah. No.
A little bit, right? I have a parentheses in the parentheses. So now we have 3 parentheses x plus 2 minus 1 squared plus 1. So you're going to combine what's in the parentheses first because you deal with your parentheses first. So this just becomes 3 times x plus 1. So previously we were working with what? Minus 1, but now we're working with plus 1, and we still should result in the same thing for the most part, right? So now we have 3. I'm going to go ahead and just kind of go through this part. We have x squared plus 2x plus 1 plus 1.
Oh, whoa.
Why?
So what happened to that first two? Okay.
What is 2 minus 1?
This is X. X is going.
What is 2 minus 1?
It's so much.
Remember, P, deal with what's in the parentheses first.
Yeah, yeah.
Okay, inside the parenthesis first. All right, questions, comments, concerns. All right, so we're okay with evaluating.
Oh, isn't this just the same as the one earlier? Or the subtracting?
I mean, it depends. Because evaluating, it depends whatever's on the inside. Okay, so the reason why we need to be evaluating or making sure we're comfortable evaluating is because we're about to do what's called composition. Okay, composition is when you put a function into a function. Okay, so we're going to compose 2 functions. Back in my day, I called it fog and gaw.
Oh, yeah. I wasn't done with the one before the one we just did. So It was like x to the fourth power minus x squared plus one. Is that right?
This one,
Uh-huh.
this, I'm showing you. Okay, all right, so composition of functions. So composition of function means that you are putting a function into another function. Okay, so when you are given the functions f and g, where x is the domain of g and g of x is the domain of f. So it's just saying they're merging. Okay, so whatever g of x is, you're not going to replace it with into f for x. So you remember how in our last example we had x minus 2? It's like putting another expression into an expression, right? And evaluating from there. You're going to be doing the same thing with composition of functions. Okay, so when we read it, this reads f is composed of g at x. So this little open circle does not mean to multiply, it means to compose. And it can be vice versa. Okay, these are not commutative, meaning that they're not going to equal each other. Does that make sense? So commutative, they're not commutative, so I'm not going to get the same result. Just like when you can multiply and add in any order, you can't do that with fog and Gauss, with composition. Order matters with fog and Gauss. All right, here we go. Oh no, you see nothing. All right, so here we have f of x equals x to the third and g of x equals 1 over x plus 2. So it wants us to evaluate plus 8. How did I say 2? I don't know either. Oh, maybe. So it says f composed of g at 2. So what this is telling us, when you're evaluating in parts and pieces. Okay, so naps. Captains, what you doing, bro? Nope, we're not sleeping. We're here learning. All right, so we have fog. So this is telling me f composed of g at 2. Okay, there's two ways of solving this. Way number one is to actually do f composed of g, which means that I would take f and plug in 1 over x plus 8. And then evaluate that. So I'm going to model both ways and then we'll go from there. So if I was to find this f composed of g, that means I'm taking g and plugging it into f. So wherever x is, it now became 1 over x plus 8. So this gives me 1 over x plus 8 to the third. Okay, then it says it wants you to evaluate at 2. So if I'm evaluating this at f composed of g at 2, that means everywhere there's an x, I'm plugging in a 2. So it becomes 1 over 2 plus 8 to the third. What's 2 plus 8? 10. So 1 over 10 to the third. And what is 10 to the third power?
1,000.
1,000. So our answer would be 1 over 1,000. So that's one way of solving it.
That was not that.
It wasn't, right?
So that you like right.
The other way to solve it is to evaluate in parts. So when you're evaluating parts, the first thing you're gonna do is plug 2. You're working from right to left. So I'm gonna plug 2 into G. So I'm gonna find G of 2. Well, G of 2 equals 1 over 2 plus 8, which equals 110. After I do that, then I'm gonna plug that output into F. So now I'm gonna do F of 1 over 10. You go from right to left.
So then you just do 1 over 10.
And then you just do 1 over 10 to the third power. And you're still gonna result in what?
1/1000.
1/1000.
Okay, so,
Okay? So either way, when you're evaluating, it's up to you. I hope so. We did it in algebra too.
I think it'd be-
Yeah, no, this is probably the one part I didn't understand back in algebra.
This is the one that's like, it has to be equal to this.
That's when we get to proving it's an inverse, but we're not there yet. But
What?
Mhm. Okay, so I would like you to choose whichever one you want. And this time you're gonna do G composed of F at 2.
Why would you do that? That's hard.
No, it's not.
Harder than putting. That's.
Mhm. So you're doing G composed of F at 2. So if you were to do the red,
So you're just replacing the X.
you're just
Okay.
replacing, which is why before we start this, we went over that, right? We practiced substituting in variables for a reason.
Yeah, okay.
So if I'm gonna do G composed of F, that means I have G and I'm substituting in X with X to the third, right? X cubed, which equals 1/x cubed plus 8.
Okay.
And now when I evaluate at X equals 2, that's gonna give me 1/2 to the third plus 8, which equals 1/8 plus 8, which is 1/16. So if you chose to do the red, that's how the red would go,
Oh, okay, see, that's simple. I was just overthinking.
probably. If you chose to do the blue, you're gonna work it from right to left. So I'm gonna plug 2 into F, so I find F of 2 first. That's gonna give me 2 to the third, which equals 8. And then I'm gonna take the answer from that and plug it into
Oh, I didn't
G.
think about doing it like that. That helps.
which gives me 1/8 plus 8. I forgot to write it out. Hold on.
That's kind of weird doing it.
So that gives me G to 8, which gives me 1/8 plus 8, which equals 1/16. Okay, I want you to see both so you can choose which way you want to approach it.
Okay.
Yeah, feel better?
I love it.
Okay, that's just when you're evaluating. So it's just a lot of substituting. You substitute and simplify, substitute and simplify. Okay, so when we look and we compare them, when I found the composition of F composed of G at 2, it's a smaller value than G composed at F. Do we see that? It's a smaller value. So that's when I told you they're not commutative, which means that I'm not gonna get the same answer every single time. All right,
Yeah, that makes sense.
okay, and it says find the composite function. So now we're gonna actually find the function. So we're gonna evaluate.
Did we just do that?
Yeah, we just need to know the beginning of the red. That's all it's asking. So now we're gonna just look at the beginning of the red and analyze it from there, okay? So when we did our red, we're taking this little guy here. And we're gonna use that. Does that make sense?
Yes.
Okay? So when I'm looking for F composed of G of X, that equaled F with 1/x plus 8, which equals parentheses 1/x plus 8 to the third. No, yeah, which equals,
Where's that third come from?
it's the power on the X. You're gonna keep everything outside of the X the same, right? You're only changing the X. So then this equals 1/x plus 8 to the third. So that's the function here. Now, when we did G composed of F of X, so that's G with F of X plugged in. That gave us G, and what was F of X? X to the third. So everywhere there's an X, we're gonna put in X cubed plus 8. And can I simplify that anymore? No, that's it. So do you see the difference in how the two functions look altogether? So they're not the same function, which is why our output is different for each one of them.
Alright, I can do that.
Yeah?
Yeah.
Doable?
I have a question.
Yeah.
How does the blue one, how does it go from like the whole thing to just like denominator?
Because what is 1 cubed? When you have a power, you distribute it to the numerator and the denominator. But 1 cube is just what? 1. Yeah. If there was a number there, like if it had been 2, then we would have made it 8, but
Yeah,
there
I'm
was no
glad you
number
said
there.
that, 'cause it's also one of that too.
See, you should ask all your questions. Okay?
Ooh, this-
Yeah. Math question. Ask only math questions, Gregory.
Wait, we take a little break though.
Yeah.
Oh, yeah. 'cause
I
we
was
do
just
that.
gonna talk about the domain. We're gonna look at the graph. Can we look at the graph and then we'll be done? We'll take a break here. Okay.
Let's get it over.
All right. So we're gonna look at the graph of each one and then talk about their domain. So for our first one, I'm gonna 2 plus 7, 1, 2. We had 1 divided by x plus 8 to the third, right? Agreed? Okay, so I'm gonna look at the graph. What do you notice about this function? It has some weird things happening, right? It doesn't look like it goes everywhere. It doesn't look like I'm touching 0. And let's look at the table. If you look at the table, there is an error. Where is there an error at? -8. And it looks like it's trying to get closer and closer to 0, but
What's
it,
after this? Like this after the idea there.
exponentials?
Can I go to the back one? Be all right?
Yeah, we're gonna take a pause after we look at the graph.
All right, good.
Yeah, I'm gonna give you all a little break. All right, so as you can see here, when we're looking at the graph, it says what's happening. Well, we have, do y'all remember asymptotes?
Yeah.
We have an asymptote at -8. And why do I have an asymptote at -8?
Oh, because the noun.
Because of the denominator. What cannot be in our denominator?
A negative, you
And
gotta be-
0. Our denominator can't equal 0, right?
Yeah.
And if I plug in -8, what is it gonna make our denominator?
Yeah.
0. So our domain is all numbers, but x cannot equal -8. And that's why it breaks. That's why there's that split. So if we go look at the graph here, what was our other one? 1
1 over
x cubed.
2
Yeah.
plus 8.
I couldn't remember. 1 divided by x cubed plus 8. And I did not put my parentheses.
Composite functions, right?
Composition, yeah.
Oh, composition.
Composite function, composition of functions. Plus 8. All right, so if I plug this in, where do you think its discontinuity is gonna be at?
The middle, at 4.
Is that the camera?
Well, I'm not sure, cause this, it's cubed in the denominator, right?
Mm-hmm. Is there a number that x would be that would make our denominator equal to 0?
Positive?
It was
-2. So on this graph, its discontinuity is where? At -2.
Why is
Does
that
it keep
again?
going? or-
Okay,
What
it
did
it's cuts there and then it keeps going.
Oh, that's.
what did you
that's-
say?
Yep.
Does it come as -2?
Okay, so let's talk about what we did.
It's the denominator.
If the denominator equals 0. So when we had f of
Oh, okay, 'cause
G of
it's
X,
cubed,
the domain was x could not equal -8. But when we had G f of x, the domain was x could not equal -2. And the reason being is here, if we have x cubed plus 8 equal to 0, what would,
okay, so
it would have to be a -2. Here, we had
whatever number would make
the denominator equal to 0.
if
Mhm.
you're-
That's where your domain does not work.
Oh, is that how it was for when we take the test too?
For the domain?
Like the last test, is that how you figured out how to do a symptom?
Mhm.
Wait,
What'd you
a
call it?
symptom? A symptom?
You meant asymptote?
Asymptote.
I was like, I was like, wait,
I've called it Simcoe since like eighth grade.
Oh, the asymptote. It is
I'm
asymptote.
gonna.
And then in my head, when you said Simtos, I heard Mentos.
Yeah.
And that's what I
that's
did. I did. Okay, so there's just more practice for you guys. And then we can pause and come back to the graph. All right, here we go. Stop.
Please, just.
All right, so reading a graph is actually easier than evaluating. Remember I said we're gonna read compositions from right to left? So you're either reading from right to left or from the inside to the outside, essentially. So if I have -2, F composed of G at -2, I'm gonna find -2 at G first. So I'm gonna go to -2, I'm gonna go to graph G, and what do I get? 4. So now I'm gonna find F of 4. So I go to 4, but this time I'm going to F, and it gives me 2. So my output is 2. That's how you do it from a graph.
I don't know.
That's
What?
I get what you mean. I mean, as long as I see 2 on there, I'll be alright, but if it's
Huh?
like
Just be
2
quiet.
graphs.
Oh, yeah, you'll have 2 graphs. Okay? What happened, Fox?
Wait, so the output of.
So you find this first, and then its output, you're gonna plug into this.
So like, for B. you
So
go
for B.
to the F, and if I go to 1.
I'm gonna go to 1 and go to, that's not 1. I'm gonna go to 1. I'm gonna go to 1 and go to F, and I get what? 1. So now I'm gonna take 1 and plug it into G. So now I'm looking for G of 1, and it's also 1.
Now, does F of F?
Okay, let's talk about F of F. So I'm going to itself, right? So I'm gonna go to X equals 0, agreed? And I'm gonna go to which graph? F. So I'm gonna go to F of 0 and go to graph F, and what is it? 0. And then it's just gonna send you back to itself, which equals what?
Yes, sir.
Okay, that's it for graphs, and it works the same for a table. Okay,
I hope.
graph doable? Yeah, okay. All right, so remember I just said it works the same for a table? Okay, so it says find G composed of F of 4. So I'm gonna go where first? And find 4. So I go to table F, go to 4, and what do I get? 16. So now I'm gonna be looking for G so I go to G, go to 16, and I get, that's how the table works.
Okay, that's good.
Is that doable? Okay, now it says make a whole new table, okay? When it wants you to make a whole new table, you're just gonna go from each to each. So if I start here on X at F, because that's where it says X on F, where does it take me? So starting here, I get 2. So I take 2, and it's gonna take me, let's follow the path. So 2 takes me to 8, 8 takes me to, so my final output is, does that make sense? 4 takes me to, 16 takes me to,
Oh, it's such a sure thing.
yeah. Same, 6 takes me to, 24 takes me to. So when I plug in 6, my final output's gonna be 8 takes me to, 32 takes me to. So I started at 8 and I finally ended at, ta-da, you composed a table. What is your very beginning and what is your very last value? Okay, make sense?
Okay.
Okay, so now it says, what did we just compute? So it says, function F converts gallons to quarts, and function G converts quarts to cups. So what did our new table now tells us? So gallons to cups. There we go. It starts at gallons and we end at cups.
So is that accurate? Rick? Is 32 cups to 1 gallon and 2 gallons?
Yeah.
60 cups to 1 gallon.
There is. You remember Gallon Man? Nobody?
Gallon.
I was like, y'all remember Gallon Man?
Little flashback.
His little-
there.
He had 4 fingers and 4 toes. Those are your 16 cups for Gallon Man.
Oh, that guy.
Yeah, your 4 fingers and 4 toes.
I've-
Gallon Man.
Still no Gallon Man.
What? What kind of first grade kindergarten teacher you had?
That just sounds like.
Gallon Man is like elementary 101. He only had 4 fingers and 4 toes, which makes 16 cups in a gallon.
Oh,
No, it wouldn't.
Gallon.
It's a gallon. Anyways, all right, undoing. So now we're talking about undoing composition. Okay, so F and G, its composition is called H. So when you look, you have to decide what was the input and what was the output. So looking at A, we have to decide what was G, what was F. So what was our input? What was our F of X for this function? What's the inside? Well, this one says X to F first. So what was the input that made this? What's inside? What's all inside? So my input was 2x minus 1. Okay, so then my outside, what's on the outside? So x to the 5th. So these 2 functions made that one. Does that make sense? If I take this and plug it into that, does it make that? So this is the baby. What's the mom and dad?
Okay, the way I'm looking at it now.
Okay, so here we go. F of X, X plus 1. G of X then had to be what? What? Square root of X. Doable, right? Okay. What made this? What was the F of X? Say it again. It's just, okay. So then what was the output? Ta-da! You found the mommies and daddies.
Keep that up real quick.
Huh? Do y'all get it though?
Yeah, I guess. I mean, it wasn't hard, but. It was
What did you plug into something to produce this?
So we're doing science class.
We're composing. We're creating. Let's call this math reproduction.
What?
Math reproduction.
Yeah,
Let's not call it that.
it's not, okay. That wasn't a good one.
Math?
It happened.
Ooh, that's a way worse.
That's what-
That is way worse.